So, how's SMARS fans? How you doing? Hope you've had a good Sunday, good weekend. Are you wanting to build your own robot? Don't know where to start, what you'll need, or how to do it? Then you're in the right place. So I'm Kevin. I'm your host. I run SMARSfan.com, and this is all about SMARS robots. So let me just bring up my notes, and we can talk about what this session is about today. So yeah, in this session we'll be designing a Raspberry Pi camera holder for the SMARS Quad robot. So let me just show you here. I've got a SMARS Quad robot just here. Let's move that out of the way there. And on the front there you can see this little camera holder. And the one that actually comes with the files for the SMARS Quad looks very similar. This is the module here, if I can sort of zoom in on that. So it comes in two parts. There's a sort of a back piece and then there is a front piece. And if we get our Raspberry Pi camera, there's the Raspberry Pi camera module. It hasn't got the ribbon installed yet. And we try and put this in there. Although it looks like it might actually fit in there, there is a very large hole at the front. And there's no way for this to actually go inside the actual holder. If I can show you that, it doesn't quite fit. So you try and squeeze it in there. There's nowhere for the ribbon to come out. It doesn't really work. And on the version that I printed out, I think it was actually the PLA that was the issue here, but this actually snapped off. So I thought we can do better than that. And I thought this is quite an interesting exercise to do. You know, how do we solve a problem like this? We want to design our own camera module holder. We've got the tools such as Fusion 360. So how do we do this? So that's what today's episode is all about. We're going to use Fusion 360. I'm going to build a new camera module from scratch. So what do we need? We need a Raspberry Pi camera module and we need Fusion 360. So that's the Raspberry Pi camera module that I've got. And what do we need this to do? Well, we need a hole for the actual lens itself. We need a ribbon hole, so when the ribbon goes into it, we've got somewhere that's come out. And what would be really cool for sort of bonus points if we have time is rather than having this round connector on the back which connects to this sort of array of, see, I've got a piece of blue tack there just holding that in place. At the moment this just kind of wibbles about there, so I just put a piece of blue tack in there to sort of hold it into place a bit. But what would be really cool is if we could have a servo that can actually position the camera up or down, a bit like we have on the I'll just pull one of these up here. Bit like one of these module holders. So there's essentially two parts to that. If we just move this away, this is the forklift thing. So there's a servo holder in there. You can just see the servo horn there, and then this slides into the top of the SMARS. So it'd be cool if we could have something like that for kind of bonus points. Might not have time to do that today, but that's certainly where I'm thinking we should go with this. Okay, let's get back to our keynote and back to that. So that's what our requirements are for this solution. And the dimensions. So this is all about measuring things and being quite accurate with this. So I have a pair of digital calipers, and these things are actually on all the time. I don't know if this is just a cheap digital caliper. However, it appears to be switched off. As soon as you sort of move this in any way, if you just sort of open this up, you'll see it sort of springs into life there. And there's a tiny little watch battery in there. And because this is essentially always on, these things don't last very long, the batteries. So I've seen people sort of hack them together where they've got a battery stuck on the top or duct tape to it or whatever. Just something that irritates me. That anyway, so we have our calipers, and one of the things we'll be doing is measuring exactly what the dimensions of this are. So for example, on there you can see that's roughly 24.8 by about 24. It says 23.93, so it's about 24.8, 25 by 24, something like that. So we have some measurements that we can start taking there. And we have to measure things as well, like the height of this thing. So what's the total height, including the little ribbon connector there. So if I sort of show you that there, just in a little window, you can kind of see what we're getting out there, and that's saying about 9.4, something like that. So I've written all these measurements down, and what I've actually done is model this in Fusion 360 as a component that we can pull in, because then it's much easier to sort of build around that, because essentially we want to get this and then we want to encase it in some kind of module that's got the right connectors and the right holes on, and then slice it down the middle. So it gets quite an interesting problem to solve this. So that's our starting point. So as you can see, or maybe you can't see there, but I'm going to help you with that in a moment. I've modeled this, and in Fusion 360, once you've designed something, you can actually create a sheet from that, a drawing that has all the measurements on with all the different views. So you can have a top view, a side view, front, back, all the different orientations. You can even do sort of a section analysis where you slice through the middle of it if that's something that's important. But what this means is that you can pass this to somebody else and they can recreate this very easily. So I'm quite a big fan of these, and it takes me back to my days of high school when we used to do, what do we call it, graphic design, or I'm sure, I don't know, technical drawing, that's what we called it. And we had, pencils, and we had the big, the big sort of boards where you'd get the paper on there, you clip it on, and you'd sort of have to draw out things. And we drew things like the Volkswagen logo. I remember that being one of the things that we had to learn how to draw. And this is kind of the thing that we had as a sketch to draw from. So that's our starting point. So I've created that as a drawing, and you can get a copy of that if you want as well. So I've created that as a PDF. What we want to actually end up with is kind of a module that has the Raspberry Pi in the middle, and it's going to be encased by a top half and a bottom half. And the idea being that these top half and these bottom halves are sort of perfectly designed so that they have all the supports and everything needed. So that thing is snug and it's enclosed properly. So that's what we want to do, and we also want it to look like the SMARS kind of design language as well. So we'll talk about that when we get to it, what we mean by that. So like I said, there's a top half and a bottom half. There's a hole for the camera lens that's kind of the right kind of size for the camera, rather than having the great big hole that this one has. It's push fit connection, so when we print it, we don't really need to do anything else other than just push these together, and there'll be friction fit. And we have a hole as well, you can probably just about see it there, for the ribbon cable to come through. And you can see on the bottom half there, there's a sort of cutout for that too. So I've actually printed one of these. That's what I actually have installed on this guy here, and I have another one, a slightly different prototype that I'm currently working on too, which is just here. It's got a Raspberry Pi 4 just sort of dangling on the top there. It might be a 3. But yeah, it's got the same kind of module there on the front too. So let me just go back to my slides. So if you want to get a copy of the module design cheat sheet, all the different measurements and everything, you can get a copy of it for free. All you need to do is go to action.smarsfan.com/camera, just put in your email address, and you can download that straight away. So let's move on to the next bit. So if you're liking this video series, or any of the videos that I put out there, and I've put out about 34, 35 now. If you enjoy these, please do, like and subscribe. Liking the video tells me that you like that specific video and that you got value from it. Subscribing helps me, communicate to you that there is more videos out there, and the more subscribers we have, the algorithm will pick up on that and share it wider. And we want as many people as possible to be building these SMARS robots, because they are just so good for getting people started in robotics. And you don't have to just start there and then leave them. You can build them out, as we did in this series, where we looked at face recognition, we looked at speech and voice synthesis, some really cool things. And I think in future videos we'll really build them out as well. So yeah, if you like and subscribe, and then press the little bell thing, you'll know exactly when I go live as well, because sometimes I go live throughout the week, and also I release videos which are related to robotics, such as the InMove head, which I have over here. So InMove is the robot that looks kind of like a person. And it's demo time, and then I've got a note to myself there to play some cool music in the background as well, because we're going to be doing quite a lot of stuff with me talking and clicking, so it'd be quite nice to have something in the background. So I've got a bit of a playlist here that we can play too. What I'll do is I'll just need to turn down the volume a bit, because it'll be quite loud, I think, when it comes through. So let me just play that. So if I put that right down to about there, how's that? That's not too irritating. Right, okay, so what we need to do now is go over, to Fusion. And well, let's get to it. So I've got Fusion 360 loaded up here. This is free software if you're a hobbyist, if you're a student in education. You might have to find your way through the Autodesk licensing system to get the license for this, but I found it quite straightforward to do, and they're always updating the software, and this is the best software on the market for doing 3D design, especially if you want to take that and put it onto a 3D printer and print out a model. I find this is just the best software, bar none, and I have had to play with a few of them to make that assessment. So this is what we're using. I've got two setups here. I've got one view there, and I've got a slightly more zoomed in version as well that I can click. So if we're looking at something and it's not quite visible on the screen, we can zoom in on that. Okay, so the first thing we're going to need to do is create a new sketch. So, well, actually, before we do that, I'm going to bring in the camera module design, which I've previously designed. So if I just click on there, it's going to complain that I've not saved the file. So actually, the very first thing we need to do is give this a name. So we're going to call this Raspberry Pi camera module holder, really long name. There we go. And now we can actually insert into the current design this Raspberry Pi camera. So we're not going to be designing the camera module itself. That was just something I did beforehand. So that's fine, we can leave that there. And now we can create a new design. So let's do that. Let's do it on this plane here. And we can actually hide that Raspberry Pi module when we don't need it. And we can just bring it back just by pressing this little eyeball here. So the first thing we need to do is we want to capture the outside dimensions of this module and then build out from there. So what I'm going to do is I'm going to click on that. I'm going to press P to project, and then I'm going to click on the edges that I'm after, which is just kind of this edge, and this edge. So what that now means, if I just hide that again, we can see we've got some, maybe I didn't quite click that one there, do that as well. If I hide that, we can now see that we've got the outline dimensions of that brought into our sketch. And what we need to do is just draw a rectangle, which is exactly those dimensions. If I just do that, there we go, oops. Okay, so we now have that captured in our sketch, and what we want to do is build an outline around that. So there is actually a command for doing offset, it's called, and offset will offset from a particular area. So if we do -3, that'll actually offset around the outside of the camera. So this is going to be like the thickness of our case around it. So let's click OK on that. So that's our first sketch done. That's nice and simple. What we're now going to do is extrude that out. We're going to pull that out. So if we just go to our 3D view of this, what we want to do is pull this out. So I'm just clicking into that area there. I'm going to press Q to push pull, and you can see there we can pull and push the that shape that we've designed. So we actually want to pull it out about 5mm. So I'm just going to type 5 there, press OK. So we've now got kind of a square hoop kind of shape. And if we bring back our Raspberry Pi, we can see that perfectly encloses that. Okay, so next what we need to do is draw a sketch on the top of this surface here. So I'm going to click that, go to create new sketch, and let's just bring that down. Why is that? There we go. Okay, so what we need to do now is bring back the Raspberry Pi camera, and I want to draw a circle exactly where the lens center is. So if I zoom in on this, let's just zoom in on that. So exactly where the middle of this is, that's kind of what I want to do. So if I do P for project again, I can actually find that circle there. I'm just going to bring that in. That's all I need. Because that's where the light goes into the camera. Everything else is just for show, but we might actually make a similar kind of one that goes out around the outside of that as well, because it just looks nice. So what I'll do that, I might pull that one in as well. So P for project, just bring that in too, and then I'm going to do an offset around the outside there as well, and that offset is going to be 1mm around the outside, so that's fine. And that will be the gap. Everything within here, if I just sort of show, I mean, all of that area there will be the hole. Okay, so that's the next bit we need to do. So what we now need to do is go back to, we can finish that sketch actually. We can now bring everything we want to pull up, but not the hole in the middle. So just this outside area here and here. Press Q to push pull, and we're going to pull that up just 1 millimeter, like so. So now you can see how this is sort of coming together. Okay, so what we now want to do is go to the bottom half of this face here, and we want to do a push pull down on there as well. So if I do Q, I can actually pull that down by 4 millimeters. And if we look on the side there, we've kind of completely encased that Raspberry Pi within the case. Okay, so what we want to do now is fillet the edges. Let me just make sure I've done that correct. No, I've not. There's one more thing I need to do on the other side on the bottom. So let's just go back onto the bottom there. I'm going to select this face. I'm going to create a new sketch on there. Just move that to there. And I'm just going to do a rectangle from that corner to that corner there. Make sure that is, it's not quite getting it to the edge there. There we go. Perfect. So I now just want to grab that and that, pull that down by 1 millimeter. Okay, so now we've completely encased our camera. Camera's inside, there's a hole for it to come out, there's no ribbon hole yet, and it's looking quite blocky. So the next thing we're going to do, we're going to fillet these edges. So if I just grab this edge here, press F to fillet, and I push that in by 4 millimeters, and then I just select these by, I'm holding down the command key on the Mac, and that one there. We've now filleted those 4 corners. Now the reason I picked 4 millimeters is the original SMARS, if I just find one, I just pull this up here for a second, the roundness that's on these edges here and underneath here, this is part of what gives the SMARS its kind of unique look, and we call this the design language. So this design language that we use for the Mac, Mac, I've got the Mac in the corner and I'll tell you about that in a second as well. The design language for this, we want to make sure that everything that we design as a module add-on has the same kind of design language, because then it looks like it's a perfect fit and that it was always part of the original design. So it's just a little tip that we need to think about when we're putting this together. And the reason I was thinking Mac there, as well as having a little Mac behind me on camera there, that Mac Classic, when they designed that, the design language was called Snow White, and they kept that for quite a while. So all the printers that they brought out, all the mice, I think there's like a modem as well, lots of different add-ons and extras, they all had the same kind of curvature, the same kind of look, the bezels were all the same. So that's what I mean by design language. They changed that after a while because it did look dated quite quickly. Okay, so we've filleted the edges there. Let's go to the full screen there so we can see what we're doing. That's better. And what we want to do next is do a few more fillets. So let me just OK that. So this edge here, I'm going to fillet this edge, and I'm going to do that by 2. Is it 2? No, it's 4. Sorry, 4 millimeters. It's the bottom edge that's 2. So I'm going to fillet that bottom edge. F for fillet. 2 millimeters, and there we go. This is looking a lot more like what we want it to. Okay, now what we want to do now is we want to split this into 2 halves, and the easiest way to do this is by creating a plane. So what we're going to do, we're going to select this top area here, we're going to go to construct, and we're going to do an offset plane, and I know that it happens to be -9 millimeters. That's where I want my cut to be. Now that hasn't done anything, it's just put a plane on the design, and we're going to use that to create a split. So we want to modify and we want to split the body. So here, the body to split is this body here. There's only one body at the moment, which is body 1, and the splitting tool is going to be that plane. So under construction we have plane 1. So that's what's going to happen. It's going to use that to slice through and create two bodies. So if you look over here, we've got body 1. When I click OK, we've got body 1 and body 2. And if I turn them on and off, you can see there that we literally have a top half and a bottom half. So I'm going to click on here. I'm going to rename this to be back, and then this one to be front. Oops. So let's have a look. Let's just put that as front. Hey Dr. Elo, how you doing? Thanks for joining the stream. Yes, it's really flying along this new Apple MacBook M1. No problems at all with this. Right, so that's the front and back section done. And that was very easy for us to split. Now the problem with that now is that these have no kind of purchase on each other. They would literally slip and slide around. So we need to design something that's going to latch these things together. So what we need to do is design exactly that. So I looked at the original design that Kevin Thomas had done, and what he's actually created there, if we can sort of zoom in on this a bit, you can see there's kind of an inset area. It's quite hard to see because it's white and it's quite bright there. There we go. So there's kind of like a square rectangle all the way inside, and with this one there is also a sort of a wall that's in there around the outside, and these things when pushed together create a push fit connection. So it's quite strong, very simple for us to do. So that's what we need to do. We need to design that little insert rectangle, extrude it out. So that's what we're going to do next. So let's just go back to the full screen there. So let me pull it. So what we need to do is we need the back piece, and we need to turn off the Raspberry Pi camera. Have I named them incorrectly? I think I have. I think that's actually the back piece. I think that's actually the front piece. Well done if you were following along and you spotted that. Right, so we've got the back piece, and that's the piece that we want to look at. So let's get this up like so. So Dr. Elo's asking, is this for 3D printing? Yes, so ultimately we're going to 3D print this part out for our robot, which looks like so. And this part here is what we're actually going to create. It's a little camera holder, and the camera is a tiny little component like this, and we want to have this sit on the robot. So there's our robot. It's got kind of a pivoted area there as well that we need to create. And the one that comes with that design isn't really suitable. The camera module holder that was created with that wasn't designed for a Raspberry Pi. So we're just going to recreate that in Fusion 360. Okay, so there we go. We've got our holder there. What we need to do, let's just get this so we can look at it properly, and we want to create a sketch on there. Right, there we go. And what we want to do is do a rectangle. So we're going to do, let's just make sure I've got all my settings correct on here. So we've got snap to grid. I don't think we want snap to grid on, actually. I think that was getting in the way. There we go. So we can just draw a rectangle like that and then use this constraint, this coincident constraint. So if we click on that and we click on that point there, and then we click on that and click on that point there, outside edge, 1 millimeter, minus 1 millimeter actually. So let's just go and edit that again. There we go. And that's eaten into the outside of the frame, but that's fine because we've got quite a nice rounded edge there, so that's not going to be a problem for us. And what we then need to do is finish that sketch and pull that up. So if we just get to there, we can grab that area just inside there. I can zoom in. So let's just grab that area there. Press Q to push pull, and we're going to pull it up by 2 millimeters. So 2 millimeters tall, like so. I think that's what we're after. Now, what I didn't do on there was actually cut that into the top. The front piece. So what I need to do is go back into there. Instead of it being a join, I need to make it a cut. and where it says objects to cut, we want to make sure we have the front piece selected there. So what that's going to do is it's going to cut a piece out of that front piece. So if we now look inside that, if we flip this over, let's flip it over there, we can now see we've got this inner edge. So what we then need to do is go back to the back piece and then draw that same piece that we've just done again, but this time let's go back to there, back on there again. We can use the same sketch, so if we go to the sketches, we can actually make sure that's enabled there so we can see it, and then we can push pull again on that same area. So we just need that inner piece, not the whole piece but just the inner piece. So let me just zoom in a bit to get a bit closer to that. There we go. So it's just that piece there, there we go. And we want to move that up again 2mm. So we've got a cutout area and we have this now extruded piece. So what we can do to make sure that this actually works, because when we put them two together, we can't see inside it. So within the the inspect, we can do a section analysis. So if we do a section analysis there, we can cut all the way through. So let's have a look at that. We can see from there that these things perfectly fit. So that's good. Okay, so let's just go to the next bit. So what we need to do now is create the area where the ribbon cable can come through. So if we just have a look on the model that we've actually created already, we can see on there, if I get that right, where this ribbon cable is coming through there, there's a little area that's cut out just for that. So the original one didn't have that, and this is something that we need to put in there. Okay, so we can turn that section analysis off just by going down to section analysis here. So analysis, open up that little disclosure triangle, and we can turn off that, that little eyeball there. So we only want to see the back piece, so we can turn off the front. We can just get a better view of that. And we're going to do it on this side here. So if I move this round so that that's the area we want to do the sketch on, click sketch, and if we click slice, that will slice through because we're going all the way through the device. My camera's gone off again. Something's really not happy, and I think it is this hub. I think it's just not very good quality. I'll have to look to replace that this week, I think, with a much higher quality hub. I think it's like a USB 3 hub, and this is Thunderbolt 4, which is far superior to all that. So I think that's what the problem is. Everything's glitching out on there. Okay, so now we've got that, let's zoom in a little bit so we can see a bit better what we're doing. There we go. And we need to do a quick design, which is 16.5mm from that center point. So let's create a line with L, and if we press X, it will enable this construction line. If we just do a normal line, let me just show you what that looks like. It draws a solid line. If we want to make that line dotted, as in it's only a construction line, we can click that, or I just get rid of it altogether. When I press L, I can press X to enable that construction line. And I want to go to this center point here and pull this some way down. Doesn't have to be specific height, but that gives us a nice section from the middle. And then what we want to do next is create a rectangle. I'm just going to draw a rectangle like so. We do want that to be a solid one though, so I'm going to make sure that these lines, just highlighting them, pressing X to switch off the construction line. So like so. And in the middle of here, there will be a midpoint. So if I just grab this and make sure that the midpoint of that is the midpoint of this line here, that's now exactly in the middle of this this piece, this back piece. So what I want to do now is dimension that. So I'm going to press D for dimension. I'm going to grab that line there, and we want that to be 16.5. 16.5. Like so. And it doesn't matter what the length of this is, as long as it's deep enough to cut through. So what I'm actually going to do is make that very bottom line collinear with that line there. There we go. So let's just get a better view of this. So if we look at this like so, what we want to do now is just push that through and cut it out. So we can do that a number of ways, but I think it's easier to sort of grab it from there, highlight the area, press Q to push push it all the way through like that, and then on the options that we have here, which is just behind my head, we can say the distance is all, so go all the way through, and the operation is cut because we want to cut it out. And there we go, we now have our hole all the way through. Okay, so next what we need to do is the camera module itself has this little ribbon connector. I'll just bring it back in there. You can just see there, it just sticks at the bottom there, this sort of black section with a white connector on it there. But the rest of the module hasn't got anything to sit on, so we need to create like a little thing for it to sit in, a little channel. So we need to create two little lines that can sit at either side of the components. What we need to do next then is just create these little channels. So let me just bring this round. So I'm going to go to the top view and then just spin it around like that, and then on this bottom face here we're just going to create a new sketch with these two rectangles on it. So let's just do rectangle 1 like so, and that's going to go all the way down. Let's just do it like that, and then another one like so, and then we can dimension these out. So we want it to be 3 millimeters from that edge there. So let's just do a dimension of that edge there for 3 millimeters. And then this one we can click, and instead of typing it we can just click on that 3. Let me just show you there because you can't quite see. So I've done 3 millimeters of the dimension, and where the dimension is there we can just click on that 3 and it will copy the dimension like so. And then what we then need to do is just make these coincident with that bottom corner there. So if I make that coincident with that, and that coincident with that, then we have what we need. So now we can pull them up. So if I go back to there, I select it, press Q, and select the next one, press Q. Now we want to pull it up by 3, and actually those dimensions were incorrect. So if we go back to our sketch, we can just edit that one there, and it should actually be 1.5. like so. There we go. And because they're both the same, it's updated the other one. There we go, that's good. Okay, so what we need to do now is flip it over and create this connector that's on the back piece. So this connector piece, which is it's an interesting sort of design. I don't know if we can get a really good view on this. Let's see if I can get it really close to zoom in. So it's kind of got a round module. There's a circle, and if you can just see there with the try and get the right angle on this. So there we go. It's got like little dots all the way around, and they sort of grip. That's the idea. So we need to create those little indentations as well. Okay, so let's go back to our screen. So let's flip this over. So we want to go, instead of being on the top, we want to be on the bottom. So let's just flip this round, and let's create a sketch on the back. Okay, so we want a rectangle on here, and we want the rectangle to be like so, and let's dimension it. We want it to be 8 by 10. 8 by 10. Okay. And what we want as well is this to be exactly in the middle of this piece. So what I might do is create some lines from here. So one line from there down to there. You can just see they lock into place from there to there. And I'm going to make them construction lines, because if we don't have them construction lines, you see how it's highlighting various different parts here? We don't want that. We just want them to be there for our internal use. So if we do that, if we make them construction lines, it doesn't now select them. It doesn't see them. They're just there to help us. And in the very middle where they both coincide, we can create a point. So let's do that. Create a point. And now we can do the same with this rectangle. So we can create a line from there to there, from there to there, make them construction lines, and then add a point. So X and X. And then right in the very middle of this, we can create a point. So let's do that just there. Okay, so now we can do the coincident. We can have that point be coincident with that point there. And there we go, that's now exactly where we want it to be. So next what we need to do is extrude that down. So let's finish the sketch there. Let's just move it so we can see it better in 3D, and we're going to select the entire area there, press Q to push pull, and we're going to pull it out by 13.3. That's the dimension that we need, so 13.3. So we've got this great big block extending back, and what we want to do now is on one of these sides we want to draw a circle. There we go. And what we want to do is, using this tangent constraint, we want to connect that to the edge that's here. We want to connect the other edge to that edge there, and we want to connect the bottom edge there. So this circle is now constrained to the proportions and the outside extremities of this extrusion that we've created, and that's all we need to do for this particular sketch. And then what we're then going to do is we're going to push pull these two areas out of the sketch. So if I just select those two there, press Q, and then cut that out, and the distance is all. We've now got this nice rounded looking thing. What we need to do now is create a split down the middle of that. So what we're going to do is just spin this round here, get that particular side, create a sketch on there, and then what we want to do then is create a rectangle from that top surface. We don't know what the dimensions are yet, because what they're going to be, we just zoom in on that, is they're going to be 2.8 from the edges. So if we do a dimension from there to there, and that's going to be 2.8, and then we do the same from that edge to that edge there. Don't think I've got that then, that edge to that edge. Let me just pull that off there. From that edge to that edge there, it should be the same 2.8. Okay, that's what we're after. And then this edge here just needs to be collinear with the bottom, which is just there. Is it picking that up? So let's just do a line from there to there, and then make it collinear with that line. So that goes to there. Okay, so now what we want to do is grab those two sections, push pull them out again as a cut. So we're going to cut that. The distance is all. Okay. Right, that's looking a lot like the module now. So what we now need to do is strengthen this up a little bit. So we can strengthen this by putting some fillets on this little area just in here. So if I grab that, press F for fillet, do a 1mm fillet. I'll just show what that looks like. So if I just zoom in on that, zoom to fit. Let's see if we can zoom in a bit better on that. There we go. So you can see there's this sort of roundedness to it. And what we want to do is we want to do that on these other edges as well. So if I go back to that fillet, I can include those edges. If I do that edge there, that edge, oops, nope, that edge there, that edge there. Let's see if that's going to do what we want. That looks good. Yep, so that will give it a bit of extra rigidity, and it also looks quite nice as well. Gives it a bit of extra strength. Right, so what we need to do now is create those two circles, and those domes on the outside, and then those circles that create that sort of hold effect where it gives it a bit of extra grip. So what we need to do now is create a mid-plane. So let's do that. So that side there, and that side there. So we do construct mid-plane. We select the other side as well, and then in between those two we've now got a new plane. Let me just find that. We want to create on one of these areas here, we do it on this plane here, we need to create a sketch. We want to create a circle, which is, you can see there when I hover, it finds the midpoint of the other circle, which is just there, the other arc. So we want to use that as the middle. We want to draw a circle there, and we want it to be 6mm. So if we just dimension that to be 6, that's what we would need. And we want to extrude that out. So before we do that, we can actually finish on this particular sketch all the detail that we need for these other details. So we need a line, so we're going to do L and then X, so we've got a nice dotted line. We're then going to do a circle on that line there, and the dimensions of that circle are going to be 1, and we then need to do the tangent between that edge and the circle, so that's nicely aligned to it. And actually I don't want it to be a dotted line, so I'm going to select it and press X to make it solid. And what I want to do now is a circular pattern so that this goes all the way around the edge. So I'm going to create a circular pattern from that particular object. The center point is that point there, and we want 16 of these all the way around. So if I click OK there, we've now got 16 circles all the way around. That's great. So we can end that sketch. We can now grab that middle circle, press Q to push pull, and we're going to pull this out by 1.75. I found that to be the best. And the reason we created this mid plane is because we want to mirror that across to the other side there. So we can actually select that on the timeline here, this extrusion. We can go to create and mirror. And we select the object because we've already selected it. The mirror plane is going to be there, and you can just see that on the other side now it's mirrored that across there. Okay, we're nearly done with this bit, so we now need to fillet that edge. So if we just select that and select the other edge as well, which is that one, press F for fillet, and we're going to fillet it in by, is it 3 millimeters? There we go. So we've now got the dome effect that we're after. Just see that now. And what we want to do next is we want to push those small circles that we created all the way in by 2.5 millimeters. So if we enable that sketch so we can actually see them, that means we can now select them. So let's go and select them. This might be a bit tricky, so I'm going to have to zoom right in to do this. Let me zoom right in. And what we need to do now is press Q for push pull, and we want to push them in by 0.25, so that's minus because that's actually coming out. There we go, they've now gone in. So if I turn off that sketch, you can now see that they now go inside, but they're quite rough. There's quite a sharp edge to that. So the next thing we want to do is fillet those edges by 2.5, and then we can mirror that across. So again, we just want to select the outside edges of these. Now that we've selected them all, we can now press F and then 0.25. There we go. And we want to also select the inside edge as well. Press F for fillet. And I think that is, let's try 0.5, see if that works. Yeah, that's good. Okay. So if you look now to see that, you've got this dome and you've got this sort of gripping effect around the outside. So what we want to do now is mirror those. So if I go to where we created them, so there was that one and that one. It's on the bottom timeline. I'm selecting all those 3 features. And I'm going to mirror that using the mirror function. We're going to select the mirror plane as there. I'm going to click OK. So now we have our dome sections. We've got our sort of I don't know what you call them, those bits that go in. We can get rid of our mirror plane, construction plane off the view there. And we are not far off finishing this now, so let me just go through the notes and see what else we need to do. I think we just need to do the top hole for the camera, and I think we're then done. Yes. So let's go back to the front piece, and let's flip this round. There we go. And this is similar to the bottom piece in that there is 2 areas either side of the lens. So if I just show you that there, either side of the lens, where the lens is sort of stuck up, we need to create something that can just give them a bit of support so the camera can sort of be pushed through like so. So we need to get that area, that face inside. We need to create a sketch, and we need to create some rectangles that are 5 millimeters from that edge there. So if we do that to there, we just dimension that to be 5 millimeters. We do the same on the other side, so from that corner to somewhere on the bottom, make them the same as that dimension there. Hopefully you can see that. So they're 5 millimeters and 5 millimeters, and then we need to end the sketch and then just push pull them out. So that one and that one, Q to push pull, and we want to pull this out by 0.5, so not very much. So 0.5. There we go. So there's just a very slight lip that you can see. Okay, and finally the bit where the ribbon cable goes in, we need to, let me just find that on there, we need to just cut out a section of the bottom piece. So on this bottom piece we just flip this round, just here, this area here and this area here, I mean let's just spin it round so that's on the bottom. We just need to cut out a little piece because that isn't quite wide enough for the ribbon cable to sit on. So what we can do is just create a sketch on there. Let's just zoom in to fit, and let's just create a rectangle roughly where we want it to be, and then let's just add some dimensions. So from that edge to that edge there should be 2 millimeters. Let's see if it's happy with that, and then from that edge to that edge there is also 2 millimeters, and the height of it is 8, so the height of that is 8 millimeters, and that bottom edge is collinear to there, and that's it. So then what we then need to do is just cut away those pieces that have just been created there, and we are done. So let's just try and grab that piece and make sure that's got it okay. Yep. And we want to pull that down to this bottom face. So where the distance is, we say to object, we click the bottom face and we cut it out. That's exactly what we need. Perfect. So that's the bottom piece done. We have a top piece and a bottom piece. Let's have a look with our section analysis to see when we've got the two pieces stuck together. And let's also include in there the Raspberry Pi as well. So if we just come and enable that again, let's have a see what that looks like. So you can see there, this is now sat nicely in there, and that will work for us. Okay, so the ribbon cable can come out the bottom there, which is good. Okay, so what we need to do next then, let's turn off that section analysis. Let's have a look at it. If we wanted to add some colours to this, we can press the A key for appearance, and we can just do a search on there. So if we just wanted to look for some white plastic, we can quickly find some pieces that look right for us. So we've got ABS, we have plastic matte white. Let's throw that on there, see what that looks like. And then for the bottom piece, I'm going to do a yellow plastic. So let's just do yellow plastic. Oops. Try that again. Yellow plastic and yellow matte. So if I just drag that onto there, so we've now got a top piece and a bottom piece, which are kind of color coordinated. There we go. That is what we were trying to create. So if we want to save that out and actually 3D print that, this is really easy. So we right click on each component. Oh, there we go. We can do save as STL. And if we just save that out, there's a little menu here. We just click OK on that. And it's going to ask us where we want to save this. So if I just click OK there, and then do the same with the front piece, I'm going to just right click, save as STL, click OK, save that as front. And now if I just go into my Finder window and I go into that folder where we've just created these, let me just bring this up as a date sorted. So we've got two files, we've got front and back, and if I show you that one there and then that one there, we can now bring them into Cura and print them. So we've now created a piece from scratch that our Raspberry Pi camera fits in, and we know it fits because you know, we've looked at this. We can look at it with the section analysis and we know that it will perfectly fit within it. And we've designed it around the dimensions of the camera that we started out with, so we know this is good. If when we print this we find that it doesn't actually fit, it's probably down to the measurement and we need to go back with our calipers and just remeasure things. But overall, that should work fine. And I've certainly printed out 2 of them using this exact design, and it works fine. So there we are. Let me just save that. Click OK. And let's go back to our keynote. Let's have a look where we're at. So, as I said there, you can save the top half and the bottom half using that save as STL. And that means that we've then got a copy of it forever. We can share that on the Thingiverse, which I have done. I'll update the link in the description below. And that means that we can share that with other people. They can look at it. If they have a design like this, they can build upon it. If they have the instructions on how to do this in something like Fusion. So I'll write this up and put this on SMARS Fan as well. So comment of the week, we have quite a few comments. So let's have a look at this. So Uday says you're taking SMARS to a whole new level. Awesome work. Thomas says, this is exactly what I was looking for. You're a brilliant teacher and a fantastic human, and I've been looking for a project to do with my child, as this is perfect. Thank you. Thanks, Thomas. B Tutorial says, nice projects. And Patrick, who I think is the commenter of the week, he says, thank you for this. I'm printing the first parts of my SMARS at the moment and ordered a HC08, which is a Bluetooth module that works with iOS. Hope this works fine. Have a lot more to watch of your content, I think. And he said his son, who's 6 years old, is also very interested in robotics and can barely read, but I'll do this together with him. It's never too early to start learning important things. Couldn't agree more, Patrick. So thanks for your comment there. Really appreciate that. So we're getting more comments. This is always a good thing. If you haven't been to the website yet, please have a look at that as well. So go over to smarsfan.com. that way and have a look on there. You can find all the tutorials, all the code, all the instructions, these design notes and so on. And the other thing worth mentioning as well is that we have a new video every Sunday. So Sunday 7 PM Greenwich Mean Time, and there are some of the other time zones below as well if you're not in UK. If you're based in America, you can see some of them in the first column there, in Canada as well. Middle ones are sort of the European and Russian ones, and India and Pakistan, and then we've got some of the other ones over in Australia on the right hand column there as well. So something for everyone. So let's just go back to our keynote. So yes, new video every Sunday. Can't emphasize that enough. And I will get a new hub, and these will be a little bit slicker. I appreciate this one dropped out and changed streams. I will have to try and figure out how to bring them all together in a single video after I've gone live with this. I'll probably have to download them and put them into Final Cut, something like that, but we can edit all that out and it'll look seamless, I'm sure. So next week we'll be looking at a new series, SMARS Playtime, so how to have fun with these robots. We'll be looking at something called Jupyter Notebook, which is a really cool Python programming tool. We'll be looking at some of the things we've previously looked at, but we'll look in a bit more depth from a sort of fun perspective. So line following modules, racing, obstacle courses, vision, and SMARS Lab, where we'll have some developments in there. And I did mention about my other robot that I'm working on. I'm not sure if this overhead camera is working or it's completely on the blink at the moment. So I do have this other robot here. And one of the things that somebody recommended this week was, I don't know if I can show you this on the screen. This little device here is a servo tester. So if I switch on my power supply and I move this little knob on here, let's see if I can do that. Look at the eyes, you can see the eyes are looking left and right. And there's a little mode selector on here, so you press again, that's dead center, and you press it the next one, and it'll just do a sweep test. So that's really handy if you're building something that uses servos and you want to make sure you've got like the dead center, which is that one there, or if you just want to play around with it like that. Pretty cool. So that's one of the things I'm working on at the moment. This is my InMove robot. He's got his little Santa hat on as well because it's Christmas currently. If you're watching this in the future and it's not Christmas, it was when I recorded this, or near enough so. Okay, so I think that's everything for this week. Yep, that's everything that's on my slides anyway. So thanks for watching, thanks for sticking with me throughout this, and I shall see you next week for some SMARS Playtime fun. So thanks for watching, and I shall see you soon.